About the evolution of Internet of Things, IoT. Now see this example, evolution of Internet of Things. So this is the evolution of Internet of Things. Uh, Now from the pre-internet to internet of the content, internet of the service, internet of the people, internet of the things. Pre-internet was like a fixed and mobile telephony, SMS. So in the pre-internet we was able to connect with the people on the mobile telephone and SMS. Now internet of content, where www comes, word webs services come, email, information, entertainment, and then you have your, first of all we see there human to human, then www worldwide, email, information, entertainment, internet of service, web 2.0, e-productivity, e-commerce came, Amazon and Flipkart, e-productivity, e-commerce, then internet of people, social media, Facebook, YouTube, Twitter, internet of things, machine learning, identification, tracking, monitoring. So is a smart plus smart plus smart. So we are making ourselves smart and smart with these things like smart network, IT platform and services, and other things. IT platform and services. Yes, so IT platform and services. Now, evolution of IoT over the years. Evolution of IoT over the years with the rising adaptation of the internet. Now, rising adaptation of the internet meaning what? With the rising adaptation of the internet of things, the modern world is becoming broader and faster in terms of connectivity. As we know that uh, modern world is becoming broader and faster in terms of connectivity. As we know, IoT refer to the millions of the physical devices that are connected to the internet and provide a platform for every industry to foster innovation and productivity. Although the technology is not the infant stage, the potential it's hold for the businesses is massive, and it's represent the next evolution of the connected world, where it would not remiss to say that interconnectedness is the new normal. The timeline of the IoT evolution. The evolution of the IoT as it stand for today began just a few decades ago with the development of the ARPANET, the first connected network, and grounded in today's internet. The history of the IoT of the milestone moment, which we will chronicle below, like 1982. A graduate student in Carnegie Mellon University Computer Science Department want to know his department's soda vending machine has a cold soda bottle but doesn't want to go all over there to check as the machine is quite a distance from his classroom. So with the help of two fellow student and research engineer, he developed a code that can let anyone on the university ARPANET monitor the status of the vending machine, whether it has soda bottle and whether they are cold or not. The evolution of IoT began here. 1989, English computer scientist Tim Berners-Lee proposes the framework of the World Wide Web and lays the foundation of the Internet. 1919, MIT John's Romike invent it can turn it on the internet. It was connected to a computer and there was no Wi-Fi then, but a toaster is considered to be world's first IoT device, the first things in the internet of the things. 1993, Courtney Stafford Forcer and Paul Giartesi from the University of the Cambridge built the Torsion Room coffee plot in their computer laboratory, where an image of its interior is uploaded to the building server thrice every minute for the people to check the level of coffee when they want a cup. 1999, current executive director of the Auto ID lab at MIT, Kevin Ashton, coins the term Internet of the Things in a presentation he made at Procter and Gamble (P&G) about linking RFID in their supply chain to the things internet. 2003 and 2004, the term IoT started being used widely in the mainstream publication like Guardian and Scientific American. 2005, the United Nations International Telecommunication Union acknowledged the impact of IoT and in its report 2008, the first IoT conference held in Zurich, bringing together researchers and practitioners from the academia and industry to take part of the sharing the knowledge. In the same year, the US National Intelligence Council recognized IoT as one of the six disruptive technologies. In 2011, Cisco Internet Business Solution Group (CIBSG) announced in their white paper that the true birth of IoT was between 2008 and 2009, where the number of the things connected to the internet exceeds the number of the people connected to it. The conclusion: the future seems ripe with the host of the endless possibilities, which only goes to show that the evolution of Internet of Things and the growth of the IoT technologies has gone past and point of no return. Technology today is not only pushes past barricade we once thought insurmountable, but also move us toward the world where the equal access of the internet and its resulting technologies marvels will be available to everyone. IoT will continue to evolve in many ways which will amaze the astound us, ultimately creating true limitless potential for everyone with the Internet of Things. Now the Yum to Yum and IoT Internet of Things. The key difference between IoT and Yum to Yum is that IoT Internet of Things connect any device to the internet for better performance, and Yum to Yum connect the two or more than two devices than internet of the data sharing and analytics. If you want to know difference between IoT, let's wait 1 minute. First of all, I explain this one, the IoT versus M to M. What is the difference? So internet of the things can connect multiple computers, multiple platform with the internet, where internet of things the M to M can connect to the with the and AI to connect with the one same things with everyone. So M to M is this diagram you can understand, and internet of things with this diagram. Now we will see the difference between internet of the things and what is this. The internet of things is the subsequent phase in the evolution of the internet, connect every device, vehicle, appliance and internet with the sensor embedded with almost everything. IoT services also include collecting and analyzing data from the connected device, enabling companies to gain the insight into their operation. The market of the IoT is expected to continue to grow with the increasing rate of the adoption of IoT applications. IoT is a network of infrastructure that connect objects to the internet to send and receive data. IoT is a recent concept for device application sensors and actuator are connected by internet. The IoT network connect things such as street light, parking meters, home application, and even clothing with the internet. The IoT allow these devices to communicate with each other and exchange data. These devices collect information from their surrounding and one another and send to the network. The data can be accessed from the range of the connected device, including mobile phone, laptop, cars, and even freezes. So, what is the main purpose of the IoT? The primary purpose of the IoT is to create an intelligent environment for the users. IoT also brings the revolution in the process of the manufacturing and management in different sectors. It provides a new way to interact with the object in the real world by capturing real data from them. What is the M2M? M2M technology solution. M2M is a system that allow machines to communicate with each other with the humans. It is an extension of the Internet of the Things. IoT that allow for the easier and more direct access of the data and functionalities of the connected device. M2M is a standardized technology for managing and sharing the data and managing and sharing the data, that is functionality connected device. M2M it is used to applications such as metering, automation, tracking healthcare, and many other. Machine to machine communication is the exchange of the information between machines. The M2M is a network of physical objects capable of the capturing information about their state, communicating that information over network without requiring human interface, and using that information to control their operational behavior. The most prevalent form of the M2M communication is data exchange between objects in the utility metering context, such as smart electric meter in home and businesses. What is the primary purpose of M2M? Primary purpose of machine to machine communication is to enable machine to machine interaction, which has been proposed as a specialized application of the Internet of Things. M2M communication allow for the smart object to communicate with each other without the intervention of human. For example, smart meters are independent devices that measure the electrical power consumption in the real time and communicate it wirelessly to the electric utility. The system of the smart meter can provide uh, instantaneous information about power demand for the large area. M2M communication is rapidly developing technology and it is both immediately and long-term impact on all areas of life. So key differences IoT and M2M. Internet of the Thing is the network of physical device, vehicle, home application, and other embedded with electronic software, sensor, actuators, and connectivity, which enable these things to connect and exchange data, creating opportunities for the more immediate integration between physical world and the computer based system. With the regard of M2M, machine to machine communication, there are the several differences. The M2M communications are used to connect machines to machines within the small same cellular network. The IoT is the used to connect machine to machine across different cellular networks. Difference between IoT and M2M. Basic IoT and M2M. So abbreviation: Internet of Things, machine to machine communication. IoT: sensor automation, communication directly between machine. Connection: the connection is by using various communication type. Print to point connection. Communication protocol: HTTPS, CFTTP, etc. is communication technology and traditional protocol used. Intelligence: objects are responsible for the decision making. Observation of the same some degree of intelligence. Technology: hardware and software based technology. Hardware based technology: the data delivery depending on the internet protocol. Devices can be connected through mobile or other network. Internet connection: active internet connection is required. Devices do not rely on the internet connection. The scope: many users can connect at this time over the internet. Communication with a single machine at a time. Business type: B2C, business to customer, and business to business. Only business to business is used. OpenAI supports IOE support OpenAI integration. M2M does not support OpenAI API. Data sharing: data is shared with the applications that it intend to improve the end user experience. Data is shared with the communication parties themselves. The conclusion is the connection is the big difference between the Internet of Things and machine to machine. Will IoT is generally any device that connects to the internet for the better performance. M to M is the usually connection of the two or more devices with the internet of the data sharing and analytics. IoT can have the compromise the stable layer, which is known as perception. So first one is perception layer, and transport, edge, processing, application, business, and security layer. So you can remember this: perception layer, transport, edge, processing, application, business, and security layer. So by using computing in the proper way, we can have the IoT device can communicate with the each other seamlessly. As a result of the connected device, and smart device can communicate with the various reliable APIs. In this way, networked technologies are made possible by cloud computing. Now, talking about what is cloud topology. Network topology is the visualization tool that show the topologies of the virtual private cloud (VPC) network, hybrid connectivity to go from your promises network, connectivity to Google managed services, and the associated matrix. This is the cloud computing works, and the SaaS and this is type of the how the cloud computing works. You can see here infrastructure as a service, desktop as a service, platform as a service, software as a service. Cloud services work on the cloud provider. Imagine you are using the Google Cloud, internet provider Google Cloud, and Google Cloud is for the software as a service, platform as a service, PaaS, TaaS, ICE, like infrastructure as a service, and desktop as a service. So what are the protocol in the IoT Internet of Protocol? First is ISTTPS, like in the most common protocol that is used for the IoT devices. When there is a lot of the data to be published, however, HTTPS protocol not preferred because many of the region. Advanced message query protocol, transmission control protocol, Ethernet, user data gram protocol, XMPP, Bluetooth low energy, and others. Talking about the application for IoT above, despite the lot of the biggest use cases cited, the popular press and many books seems section by understanding the technology. IoT can be applied these board areas: consumer, home, and personal network. Consumer in his her automotive vehicle, industrial and office applications, homes, and are easy frontier and to deal with IoT. A typical American home contains home application, entertainment systems, temperature and humidity control uh, system. It is easy to see how the user will be able to manage some of these devices using the Internet of the Things. So this selecting the best network option for the IoT device. However, it requires a careful look at various factors for each situation. The scale and size of the IoT network, data throughout the transfer requirement, the eventual physical location of the embedded device, the battery size and physical size, etc. Let's learn some of the three most network common network: low power wide area network, PAN and LAN. B, so that these areas application, the low powered wide area network, personal area network, and local area network. Only the low powered wide area network is in our IoT solutions. So uh, the low powered wide area network is used as one of the most efficient technologies in our IoT solution. Networking concept: low power networking, low power area network, and low power wide area network combines with the high network coverage and low energy consumption, so that devices with the conventional battery can be operated for several years without any problem. At the same time, a large number of the participants can integrate it into the network. application areas. With the help of our innovative IoT solution, we can achieve their monitoring and control our saving goals in a timely manner, increase the transparency, efficiency, and continuity of the business process without the manual effort. In the simple form, the low power WAN, low power wide area network technology that interconnect low bandwidth battery powered devices with the low bit rates over long ranges. IoT connectivity, comparing NB IoT, LTM, LoRa, Sigfox, and other LPWAN technologies. On LPWAN technologies, we covering some of the basic what LPWAN is and some of the benefit of the LPWAN. Over other connectivity option in our second installation of this series, we will compare some of the major LPWAN technologies. So LPWAN technology, while there are the many LPWAN technologies standard, we will focus on Sigfox, LoRa, Symphony Link, and Baitless. Although there are the other priority protocol and stakes such as Day 7 Alliance protocol, they have not gained as this. So LTEM and narrowband, also NB LTM2 are expand have emerged now, big 5G sweeping over the horizon. LPWAN technologies in this space in order to be well prepared for the future transformation in the connectivity option. NB IoT and LTEM. LTEM is a narrowband IoT are promising additions to the LPWAN space. LTEM is the third generation partnership project, commonly known as a 3GPP, response to intense interest in the LPWAN solution that piggyback on the standard LTE connectivity while preserving resources. NB IoT is another 3GPPS construct challenging and the disruption Sigfox and LoRa. The alliance unite, however, NB IoT different from LTM in the operate outside of the LTE constant. One big advantage of the NB-IoT is due to the simpler waveform. The technology consumes minimal power. Another big advantage is cost by choosing chipset specifically engineered for the NB-IoT protocol, which has a simpler construction to overall component, and cost is also reduced. LTEM has a notable advantage. First, it has the higher data rate, which is important for the data rich use case, and unlike NB IoT, the front end is relatively similar. The simple, however, in the addition of LTE being primarily a US technology, there are other limitations to consider. In general, larger economy and practical forces might shape the NB IoT versus LTM debate. LoRa. The LoRa Alliance is an open non-profit or association formed to foster an ecosystem of LPWAN member companies throughout the North America, Europe, Africa, and the Asia. Its a founding member include IBO, Microchip, Cisco, Semtech, Bogegas, Telecom, Singtel, KPM, Swisscom, Fastnet, and Belgacom. LoRaWAN is the open standard networking layer governed by the LoRa Alliance. However, it is not truly open since its underlying chip to implement a full LoRaWAN stack in the only available by Semtech. Basically, LoRa is a physical layer. The chip LoRaWAN is the MAC layer, the software that supports the chip enabled networking. A more detailed yet simple introduction to LoRaWAN can be found. Sigfox, founded in 2009, and it is the French company based on the Lebex, France. Sigfox had a significant transaction in LPWAN space due to its successful marketing campaign in the Europe. It also boasts a vast ecosystem of the vendors, including Texas Instruments, Silicon Labs, and Axon. Recently, Sigfox has invested most of its effort into the rapidly accelerating European market. They considers for the US focus adopter. Sigfox uses the proprietary technology, for example, of using slow modulation rate to achieve a more extended range. Due to this design choice, Sigfox is an excellent option for the applications where the system only need to send small infrequent burst of data. Possible applications include parking, sensor, water meter, and smart garbage cans. However, it also has some drawbacks as sending data